Start the recording. Question is that if the file is remote, then job tracker is not taking, there is no data locality optimization happening. Okay. So, so whenever you are accessing the data which is remote, there is mm, no data locality optimization happening. All right. So job tracker basically will have to bring the data from the remote to get that work done. All right. So that's about it. All right. Coming back to the question. Now there is a question from Deepak. What will happen if we are loading data in a table and the location is having more than one file with the name of that location? So the location when we refer to generally means a folder. All right, Deepak. So the location of a table, so the location of the table is a folder, not the file, and therefore the data in the table is represented by all the files in the folder. All right, good question. And right, so so we're talking about something called views. What does it mean by views? So whenever you have a complex query, you break it down into smaller representations of the table. Okay. So for example, the view called tweets underscore clean represent this particular query. Okay. So so every time you do select star from tweets clean, what is it going to do is it going to execute this query under the hood. Okay. So the difference between a table and a view is table has some data while views do not. All right. So for example, when you say select ID comma country from tweets clean, it's going to execute parts of this query and then give you the result. All right. So I'm hoping that you are familiar with the views and when do you use views as opposed to creating a table and all that. So Leonid's question is, are views pre-compiled? So when you create a view, it's not, there is no such thing called compilation here. Whenever you are making a query on views, basically the query is regenerated and the map reduce is produced. Okay. So when we expect, what we expect from pre-compilation is that these views will have some map reduce representation already, but that's not the case. Okay. Because if you think about RDBMS, the way it works is whatever table, whatever query, whatever views you have, they are basically so in case let's think about views the way it is in the databases. So a database where when you create a view internally, it prepares a actual representation with respect to the database. Okay. Now here, in case of Hive, that's not the case because actual representation here means that it has to be converted into MapReduce. Okay, and that's why precompilation is not yet there. Okay, although there is a massive effort in to convert views into the to convert the views into I mean to have the Hive really highly performant. So there's a massive effort going on to have the SQL as highly performant. Good, very good question. Moving ahead, correct, correct, Leonid. So views are basically one level of, I mean, it's just a level of abstraction. All right. So, all right. Good, good. So just like Pig, we can also create our own UDF. All right. We can also create our own UDF so that so that the functions which are not there yet in Hive can be done. So you can say that while creating a UDF, you can create a class, extend UDF, and then whatever function you want to create, there has to be one class for that function. An evaluate function is what you have to implement as part of UDF. All right. So let me show you how does the code looks like. So first you create a custom class, then you create your jar, take it to the server, and then you create a temporary function, and afterwards you can start working. All right. Let me try to. All right. Let's say we have a function called myLower, which basically does opposite of what it says. It basically it makes it uppercase. All right. Now let's have export Hive. Okay. So yeah. Now it's created in the file system. Let's just scp download, not this. So what was the name? Export sg hive. Okay, and let's copy it to Hadoop one. All right, everything is up. So we have copied this file. Now let's log in. and all right. So here also, yeah, I forgot to tell one more thing. When Matthew was asking about this question of pig freezing up and not completing the job, this one, okay, so these are generally the connectivity issues. There'll be other tools also which will be freezing up, I'm assuming, and we can have this discussion in detail. But for all of you, there is a command called screen, okay, and you can also resume the screen. So you can start. So screen is a command which keeps running in the background, even if you're not even if you have closed the terminal. Okay, so if I run something under after running the screen, then e- even if I exit from here, it will keep running in the background. Okay, so and when you want to resume it, okay, when you want to resume it, you can simply say screen minus resume. Screen minus resume. All right, so you can use screen to basically make sure that even if you disconnect, it'll keep running in the background. All right, makes sense to you? So you can use screen, or in case you want to run something in background in Unix, you can use a command called nohup also. Screen is like a shell. I'll show you. So if I run screen here, so now this is running. And this is basically another shell which has started. If you exit, you'll go back to the previous one and you're here now. Okay. So if you are running something, okay, in here, okay. So you can try that one. All right. Okay, okay. So Matthew is saying he was running the pig job from the Hue. Let me have a look at your job's history. Then I think I should be able to diagnose the problem. All right, good. All right. So once we are done with copying the file here, once we are done with copying the file here, what would happen is we have to now, when you're starting Hive, all right, here you can say add jar and the jar name, okay, which was sg hive dot jar. Sorry, it was hive udf probably. Yeah, it is done adding that. Next is you create a temporary function. Temporary function as in you declare your function so that you don't have to refer it. All right, all right. Now let's have a look. So when I say select my underscore low effort, should it give? It should give everything in uppercase. All right, let it finish running. All right. I've pressed Control C, so it killed. And similarly, you can also call the same function in group by and other situations. Okay, so you can have a more detailed example in the Hive case. Okay, and yeah, so similar to the way we have defined our function, we can also define the way you can load the data. So for example, there is a JSON Survey library. Okay, so whenever you have to customize loading the data. Let's say you are trying to load the data which is in the JSON format. Let's say this one is in a JSON format and you want to load it as the table. So if you have these custom formats which are not there yet in Hive, you will have to create something called Survey. Okay, they are also called UDF, and all they need to do is convert an input record, convert an input record, input data into tab separated values, which Hive will interpret as columns. Okay, basically your survey, whatever you create tomorrow, will have to convert the input data into a row and its values. Say for example, here there is this survey which we have downloaded. It's called Hive JSON Survey. Survey means serializer. Serializer, SCR means serializer, and DE represents deserializer, converting a data into a form which Hive understands. And and while saving also, we use Survey. Okay. Now the there are many JSON surveys available. Sorry, not JSON surveys. Many Hive surveys available across the internet. Say, for example, this JSON survey, you can download it from here, add it, add it to your Hive installation, and then you can start using it in the following manner. You'll have to say row format instead of saying comma or tab. We say row format is a survey, and its class name is this. Okay, so whatever data is on this location will be passed through the JSON survey, and your table will be created based on that. All right, table will be created based on that. Next is ordering by. Whenever you want to order the data on a particular column, you can use order by. But the only problem with order by is it though it guarantees the global ordering, it does this by pushing all the data through one reducer. There is only a single reducer through which data is passing by. Okay, and if you have if you have humongous data, it doesn't make sense to go for a single reducer because it will overload the single machine. Okay, all right. Next is that sort by. If you try to sort the data by a particular column, okay, okay, I'll take a step back. The reason why we were using order by in earlier and why order by was having a single reducer, the reasoning was that if you try to order it based on multiple reducers, the chances would be that if you're creating two files, the partitioner has to be such that the order by works properly. Okay. So if you remember correctly, in our in our word count example, if you had seen the word count example, so if there are two reducers, part 0 and part 1 will be two files created by these reducers. All right. And these part 0 and part 1 will be well sorted both independently. So it might have apple and bat, and this one might have, okay, avocado and something like ball. Right now, if you see that there are these two files, because we have two reducers independently, both of them are sorted, but if you concatenate these two files, they may not be sorted. Now your question would be, then how do you sort data using MapReduce? Okay, the way we sort data is by using a proper partitioner. In one of the cases, what we did was we said that, let's say we had to make it proper. So what we'll do is we'll say, in our partitioner we'll say all less than say b would go into part 0, and rest will go into part 1, and this goes in part 2, all, and including all greater than b and including b would go to part 1. Now what would happen in this case is apple, okay, and avocado. See that? And all right. So if you have a good partitioner here, if you have a nice partitioner like which is taking care of the ranges, only then you can have a proper sorting using the reducers, multiple reducers. All right. So coming back to where we were, and that is why the order by was passing all of the data through a single node, but which was not acceptable. That's when the syntax called cluster by X came into play. Okay, so all you have to do is, when you want to order the data and it has got multiple columns, you can simply use cluster by X. Okay, cluster by X basically is equal to partition by X, or let me go back here. Okay, now sort by X uses multiple reducers but doesn't have a proper partitioner. Distribute by X is the syntax which makes sure there are multiple proper partitioning happening on a particular column. Okay, and then neither sort by nor distribute by was solving the problem. If you combine both of them, only then you get a proper sorting. When I say combine, it means that the we defined a good partitioner, that is distribute by particular column, and we ordered using multiple reducers. Okay, so we basically use cluster by X for sorting when the data is really huge. Okay, if you have n reducers, then the data gets divided into n files, but there are non-overlapping ranges. That means they are mutually exclusive, individually sorted. If you just combine them, you get the result. That's all. All right. All right. In the similar sense, if you are using cluster by, Okay, you are using cluster by, and you can define that these many reducers we require, so you can have those many buckets. All right, let's have a quick demo that will be easier to all of us. Okay, so there is there is a data which we are going to download, and this data is going to be in this format. It's going to have a user ID. It's a movie lens data. It's a ratings given by various people to various movies. Okay, so it's a movie lens data, so you can take this file. So so this is the table which we will be creating, called u underscore data, and then we will be loading data into it. Still stuck. That's okay, reason server doesn't matter. All right, so we will say use, what was that, July 25. You can say create database July 25, use July 25. All right, we have created the data. You can say select star from u underscore data. Nothing is there right now. All right, so it is going to have user ID, movie ID, and ratings. So there is this file which you can download, and if you remember our discussion, if you put an exclamation in the beginning of the command, it will be executed as if it's a local file. All right, so as if it's a local command. So wget locally will be executed. Instead of exiting Hive and then executing this command and coming back, you can use exclamation. All right. Although I've already done this. Okay. You can see when I say find, you can see. Oh wow, a lot of data has been downloaded here. So there was a nice. All right, I have already done that. You can see the folder. All right, and we go. So this, and in this you will see nice data which you can utilize to run couple of more tests. And out of this, what we are interested is in u.data. Okay, so we can say tail u.data. Okay, so u.data contains the user ID, the movie ID, the ratings given by the user to this movie, and the timestamp at which this user gave the details. If you want to know more about user ID, you can have a look at u.user. And if you want to know more about movie, you can have a look at u.item. All right. All right. So we can say, so have I created the table? Show tables. All right. It is done. Now I'm loading the data. It's done. And you can have, if I say select star from u.data, u_data. All right. You can see that. Now we can run various kinds of commands on top of this. Also, if you notice that this time when we said select star something, it did not run any MapReduce. It simply started reading data from the HDFS and gave us the result. But if you start putting group by or sort by or where clause, then it starts giving the, let's say I put where user underscore ID equals to 196. Okay, what was the show? Okay, user ID. Yes, user ID. Okay, now it is running MapReduce if you see. All right, now the results are here. So now you can do a complex things on top of the same data. For example, here are a few of the complex things you can do. For each movie, find out how many users voted for it. And second assignment for today's thing today is find out what is the average rating for all the movies, only for the movies which have been rated by more than or equal to 30 users. Okay, I hope the assignment is clear to everyone. Leonid, Matthew, Deepak, Kiran, John, Vaibhav. Deepak's question is that is it 30 users or is it 30 users or total rating well is 30 users. Okay, and the reason is that let's say we are computing average ratings. Okay, so all those ratings which have very few users are generally not fair. They are very biased ratings. Therefore we'll consider only the ratings for the user for the movies which have been rated by more than certain number of people. All right. No, Leonid's question is, do we use the database already set up in Hive? No, I will just delete it. Drop database, first drop table, July 25. Okay, not July 25, it is u_data, u_data, and then drop database, July 25. All right. So you can download, you don't have to download, it is this data which is we are talking about is already downloaded. So you don't need to download, but you'll have to create your own table. Make sense to you, Leonid? Matthew's question is it also posted in on the website? It is there, yes. Okay, which folder the data is in? All right. You are using it using the so I'm going to create a table called a folder called data, and under that Hive, and under that Hive. All right, let me, or I'll what I'll do is, okay, what I will do is I will give permission to my folder to everyone. Okay, so in the students folder, there is a home student, ls home student, and then asgiri slash hive. Okay, this is where most of the data with respect to today's discussion lies. Okay, great, great. So here you will see NYSE daily, NYSE dividend, also the Hive UDF jar. And if you're looking for Hive UDF in Python, I've also written a sample code here. Okay, okay. So this is another one I've written, and yeah, never mind. So all right, and it would be there in here. Let me have a look. Okay, so you have subjective assignment here. All right, and the details are also here. Okay, all right. So that was about Hive. If you have any questions, feel free to get back. And yeah, okay. So before we start our next session, do you have any questions for me? No questions? Okay. So we are starting a very, very important topic now. And the objective of the topic is, so, okay. So Matthew's question is, will we be covering JAQ, JAQL? So So we'll not be covering JAQL, but yeah, we have not covered it yet, but we can look into it. All right. So it's basically JSON query language on large scale, and we can have a look at it. What exactly, how exactly is it useful to us? All right. So, but we have not planned it yet. We have not planned it yet. If time permits, then we can have a look at that also. All right. We can make a note of this one. JQL. JQL actually. All right. So we are starting up something very, very important. And just like our normal map reduce. So far we discussed three things. One was how to store huge data in the form of raw files using HDFS. The second was how to process any data. Second part was how to process any data distributively using MapReduce. Okay. Then we talked about semi-structured data, and then we talked about the semi-structured data processing using Pig, and then we talked about structured data using Hive. All right. Now, if you have to store the data which is coming at a very fast pace, if you have to store a humongous structured data which keeps getting modified all the time, okay, in those cases, HDFS may not be useful. HDFS is mostly for completely unstructured data, and and when you have no record based editing. Okay, imagine this. If you have a huge file and this file is being updated by many people, some people want to change the line number 30, other people want to change the line number 50. And as we told you earlier, in case of HDFS, if you try to update a file or make any changes to the file, what happens is what happens is that the blocks gets rewritten, and it's humongously inefficient. It's very, very inefficient to edit a file in HDFS. HDFS is great to access the file and to write the file in an append only fashion, but if you have to edit a file, then HDFS is not useful. Same is the case with normal file systems. Normal file systems are not great for editing the records. Okay. Therefore, we require a database which can run on many machines parallelly to give you high storage space as well as high throughput. Okay. So that's where the game of NoSQL starts. All right. So why do we have NoSQL? So that you can, if you have no clue about SQL, you can write it in your CV. And yeah. All right. Before moving forward, we would like to understand what does it mean by scale out and scale up. Okay. So horizontal scaling and scale out is the same thing. So if you had one cart and you needed to carry more load, you needed to carry more weight, then then you could do two things. One is you get a better horse, or you change the horse and get an elephant to pull the cart, or you attach more horses to the cart. Okay, if you attach more horses to the cart, it is called horizontal scaling or scaling out. And if you add bigger horse or add a big elephant, then it means we are vertically scaling up. Okay, so this vertical scaling up sounds the the way which is easier to achieve. Okay, because it doesn't change any architecture, while horizontal scaling is very difficult if you have already a system running. Okay, therefore lots of people used to go for vertical scaling, but problem with vertical scaling is that after some time you cannot go further up. Okay, if the elephant is not sufficing your need, then what do you do? Okay, all right. So yes. So when I say horizontal scaling, the analogy is for databases exactly. Thank you, Matthew, because I forgot to tell you that. Okay. All right. So in the olden days, the way you it used to happen, I'll give you the war story. I think that'll give you a better context. Here it means if your database is not sufficing, putting up putting up a bigger processor and bigger RAM is vertical scaling. In case your database is not sufficing and you are able to add more machines to accomplish the task, that is called horizontal scaling or scale out. All right, now let's have a look at the war story, the way. And this is like a true story. I have seen it happening. I have seen it happening when we were dealing with Postgres, and whenever we had these huge data operations, this is like the true kind of a record. Okay, here's the story. So you had this initial public launch and you start data. So let's say you're building a website or you're building an e-commerce platform where you are generating a lot of data, and and you had planned your launch. Okay, so as soon as you launch, you just move your website from your local computer to the server, and you're pretty happy that you have done perfect with well defined schema and everything. Now, the day you do a public launch, service becomes popular. People start covering in various news, and there are too many requests coming to your server, and every request is hitting the database. Okay, so what do you do when there are lots of requests hitting the database? You basically have the cache in place. You add the memcached. Memcached is a good solution for preparing the cache. For mem in place of memcache, some people also use MongoDB. We'll cover that later. So we add the memcached to common queries. Okay, to cache the common queries. Now, once you have done that, the reads will no longer be strictly ACID, okay? And cached data must expire. All right. So basically, what am I trying to say is that the the moment you put a caching solution in place, you have made your data inconsistent. And it sounds awkward to lots of us because we always think that the caching is the solution to solve all our life problems, right? But that's not the truth. So the moment you put a cache, what happens is that in case cache is being updated, a record is getting updated, then it takes time for cache to expire and cache to update. That means till the point it gets fresh data, it will be giving the older data. So for few seconds, it might be serving the older data, the stale data. Therefore, the moment you put a cache, you have made your service inconsistent. Okay, so that's the definition of inconsistent. All right, so this is the first step. Probably every DBA does this thing. Put a cache quickly. Let's just put a cache. Okay. Next is the service continues to grow in popularity, and there'll be too many writes that will hit the database. Okay. As the service continues to grow in popularity, so many writes will start hitting the database, and because of this, because of this, sorry, you start scaling your MySQL vertically. Okay, vertically as in you put 16 core CPU, you put 128 GB RAM, and you put banks of 15K RPM. All right. At this moment, you might have increased the capacity by 10x, and you're pretty happy that you have just solved the problem forever. Okay, and this is exactly what we do in case we are launching a service. So, I mean, till this point, everybody was able to do these kind of things. So this is a story of 2004, 2005, and at that point of time, probably every e-commerce used to crash. Every e-commerce site used to crash once in a while. Now, fine, your server is running fine. It looks good, but the moment new features keep on adding. So as you so let's say at this point of time you got some funding and you started scaling up, you started hiring product managers and you started hiring developers. So as more and more people come in, more and more features will keep on adding to your website, and soon enough there'll be too many tables. Okay, there are too many tables. Every query has to join many tables to give the results, and therefore there are too many joins start happening very soon. Imagine imagine Amazon's detail page. There are around 200 features on that page. There is a price, there is availability, there is a title, there is a description, there is a recommendation, there is a byline as in who wrote that book or who is selling that product, and then available sellers and whatnot. So there are so many joins that start happening very very quickly. And the moment you have so many joins, you cannot really do anything to anything other than removing some of the tables. Okay, so when there's such a situation, so you start denormalizing as in have single table to represent multiple to a single table which combines of multiple tables. Okay, so you start denormalizing, and the moment you start denormalizing, if you are from DBA background, you will not be comfortable with this idea of denormalizing, because that's not what DBAs are taught. Okay, so and further, still on one hand you should be happy that your server is getting popular, but because of the technical problems, the server is swamped. Okay, things are slow, and suddenly you you try to stop doing the processing on the server side. When I say processing, so all the extra processing which you would like to do, this such as formatting the dates, formatting the time, and a lot of things, you stop doing that on the server side. Okay, next is that some queries will be still slow. So you keep on doing pre-materializing. Pre-materializing as in, for each query, you start preparing the data and keep that data ready for each query. Okay. And you stop joining in lots of cases. Now, after this point, reads might be okay, but writes would be getting slower and slower. So you will stop doing the indexes and triggers. Okay. Now, the moment there are no triggers, already when we said stop the server side computation, it also means that we are not going to use the stored procedures. Okay. Now let's have a look at it. What we evolved into. Okay. So we started with a perfect database with a perfect schema, but due to load, we stopped using the server side stored procedures. We stopped we had lot of caching, pre-materializing, which means data is anyway inconsistent. Next is that the data is denormalized, okay, and then you have secondary indexes and triggers which are no longer there. So effectively, the features database was providing, you are no longer using any of these features. Okay, you are no longer using any of these features. So what's the point of database? Database is just behaving like a big rows and columns. That's all. Okay. So that's why lots of people. So in one of the cases when Amazon was not able to scale up on one of the Christmas, one of the engineers came up with that we will just have key value pair kind of a designs, and that became something the first NoSQL probably. Okay, and this is the story that comes from e-commerce company with the similar problems. All right. So are you guys convinced that RDBMS may not solve problem in e-commerce? Yeah, Matthew, Leonid, Kiran, Deepak, Vaibhav. Also, those people who could not do these 7 steps and were not trained enough, those companies vanished. Okay, and vanishing means in an e-commerce world, you shut down your website for 2 days, all your traffic is gone, all your users are gone, and effectively, to gain the same kind of traction, you will have to do a lot of work. So if you're down by, say, a week, you are actually finished. Okay, that's the e-commerce story. And all right, so that's what brought about this NoSQL kind of database. And all right, again, so no matter what people tell about NoSQL, that it's for great design paradigm, it's for this and that, but NoSQL has been designed for 3 things. All the NoSQLs have these 3 things in common. First, to store big data, to give you high availability, and third is scaling out architecture. Meaning, today you have a need of 2 computers. Today you have a certain need. Tomorrow, if the need increases, you can easily add hardware and scale out. Okay. So these are the 3 things why you need NoSQL. NoSQL is this new kind of database which has very basic features and has been designed for these 3 reasons. Okay, these are basically, NoSQLs are mostly like a data store. I wouldn't call them database because To be qualified as database, you need lots of features. All right. So what exactly is NoSQL database? So the most important criteria for being a NoSQL database is the distributed architecture. It's a distributed architecture, meaning that it is running on multiple computers. Every NoSQL database is running on multiple computers simultaneously. Okay. And when you run something on multiple computers, you of course need an identifier to locate where is your record. Okay. So if you do not have a marking for each record, you may not be able to distribute effectively. You may not be able to distribute effectively because you'll have to keep a track of which rows are on which file, which machine, and therefore distributed architecture leads to one design where there has to be an identifier of each record. Okay. The full form of NoSQL has been done after the keyword was coined. So we call it not only SQL. And it's non-relational database. It does not give you primary key, foreign key kind of properties. Neither of the NoSQLs. There are 150 NoSQLs in the market with the different designs, and all of those 150 NoSQL databases have these features in common. Okay, because if you start giving non-relational, if you start try to give relational properties to NoSQL databases, then then they become slower, and it becomes impossible to maintain the relational properties, as we saw in the previous screen. All right. So, and most of these new genre of databases are open source. Reason is very simple. Whenever a new database comes into the game, they have to be open source. Otherwise, nobody will ever acquire them. Nobody will ever use such a database which is not open source in this new era. Oracle, Microsoft SQL are successful, but those are from previous uh, before 10 years. Now if you are coming with a fresh database, new kind of database, and you are not open source, nobody will ever use it, because in what if you go down, I mean you go out of business and our data gets stuck with your database. Okay. So, and next is the database has to be horizontal scalable. Almost every NoSQL is horizontal scalable, which is equal to saying distributed architecture. Schema free, if that is another thing. So none of the NoSQL makes schema as mandatory. Easy replication, because if you have data distributed across multiple machine, if there is no replication, the data might get lost. Simple API. Okay. So simple API is an excuse that to say that we don't have SQL right now, so we provide you simple API. So some of these databases, NoSQL databases, do provide SQL kind of uh, API, but most of them come with get and put kind of an API. Very simple get and put kind of API. Okay, and to manage huge data and to run on commodity hardware. All right. So this is basically the features of NoSQL databases. These are new genre of databases which are used for volume, scalability, and availability. Okay. Volume, scalability, and availability. All right. So NoSQLs are vaguely categorized into four sections. One is called column oriented or wide column databases. They are more similar to our existing table. We will talk about what do we mean by column oriented, but right now you can think about these databases as most closest to what we have used in past. These are the closest to relational databases because the data in them is stored in tables, and values are in the cell and there are columns, but there are huge differences from the normal database tables. Okay. Second genre of database is document oriented database. What does it mean by document oriented database? Instead of having data as simple like an array. So if you think about a normal database, a row is an array of values, right? A row is an array of values. So instead of having record in the form of an array of values, these document oriented database give you let you store the row in a complex format. So if your row is in JSON instead of a flat key value, array of values, you have you can store the row as a document. Okay, each row is represented as document, and this document is generally complex, meaning a document can have further documents and so on. So if you take a case of MongoDB, MongoDB lets you store the data in the form of documents, and this document is a JSON document. Same is the case with Couchbase and other databases. All right. Now, third ones called key value are the most primitive ones. Okay, you can think when you hear key value, you can think of an Excel sheet or a spreadsheet with two columns. One is key, other is value. That's all. There are no other columns. You have to keep on inserting the values and keys into this table. Okay, so when we talk about key values are most primitive database, and they started with Amazon Dynamo. So Amazon came up with something called Dynamo, and these key value kind of databases are no longer in use. Okay, people do not use them it's you know unless it's like Memcached or Redis. So, but nobody uses Dynamo. Okay, because Dynamo is out of service anyway. Okay, now Redis is also key value database, but it's in memory, as in all the data you store in Redis is available in the memory, so there's no disk IO required to access the data. All right. So the fourth one is the graph database. Graph database are the most, the newest in the industry and are still sort of in infancy because it's really complex to crawl a graph. Okay, so there are many different innovations happening in graph database, starting with Neo4j, Giraffe, and others. All right, these are the graph database to store a graph of object. Lots of problems can be modeled into a graph kind of model. Say for example, social graph and page rank, where one page is linking another is linking, so it's a web of pages. Okay, so that's graph. All right, this is the typical comparison of SQL and NoSQL databases. All right, we all know that the only important point you should remember out of this is no, the existing SQL databases are able to provide you great transactions and in the form of ACID properties. Okay, so can somebody tell me, the ACID, what does it mean by ACID property? I'll come back to your question, Kiran. What does it mean by acid properties? Anyone? Atomic, consistent. The acid property, anyone? Perfect, perfect. Thank you. So, atomicity, consistency, isolation, and durability. Those were the properties of a typical database. Those were probably by code. So, acid property was something every database has to adhere with. Okay. Now, NoSQL database does not adhere with acid properties. Okay. So, NoSQLs are, you know, they provide the partial transactions. Okay. In or let me put it in a very simple words. So, when you have a relational database table or relational database, you can do things like add one row, update another row, delete some other table's rows, and insert into some other table, and all of this in a single transaction, right? You could do those kind of things in relational database. But in case of NoSQLs, that is really difficult to do. Okay, that's really difficult to do. None of the NoSQLs provide that out of box. Okay, some of the NoSQLs provide you row level, some of the row level transactions, some of the databases NoSQLs provide you the cell level transactions and so on. So it's not standard ACID properties. So you have to keep that in mind. We'll talk about it. Why we could not provide these ACID properties. That is answered in the form of CAP theorem. Okay, it's very important to understand CAP theorem. So when researchers started working, they realized that no matter what they do, they cannot provide acid kind of properties. And why is it so? So as per the CAP theorem, so they came up with an excuse called CAP theorem. I will describe why in detail. Why does CAP theorem matter to us? So CAP theorem says that out of consistency, availability, and partition tolerance, you can only get two at most. You cannot get all the three. Okay, so consistency here means all the nodes see the same data at the same time. Okay, and availability means a guarantee that every request receives a response. Okay, and partition tolerance means that the system continues to operate even if there are loss of some machines or loss of the network. If the network is disconnected, half of the network is down, still can you can your machines work? Okay, so partition tolerance, the minimum level is that if one machine dies, can your system work well? Can your database keep working well even if one of the machines handling the load under the hood is down? Okay, so that is partition tolerance. That's a minimum level of partition tolerance is at least one computer's loss is okay. That is, one computer's loss is okay. There's a minimum number of uh, partition tolerance we are talking about. All right. So out of these three features, we none of the NoSQL database or none of the database can provide all the three features. Okay. So Kiran's question is, amongst them, which one is popular NoSQL database? And yeah. So he says that I heard only MongoDB. Yes. So MongoDB is good and popular. Cassandra is good and popular. HBase is also popular. So these three are the ones which most of the people use. Okay. There are few people who are using CouchDB and others, but they moved to MongoDB. All right. So the cap theorem says, so cap theorem is clear to everyone? The statement is clear to everyone? Good, good. In cap theorem, you can also see that the database which is in consistency and partition tolerance is big table and HBase. Okay. While in availability and partition tolerance, it is DynamoDB and these are the databases. While in case of consistency and availability, it's this section is your relational database. All right. Now coming back to the question here. All right. Now, why is it so? Why is it that cap theorem applies to most of the systems? Okay. Let me try to answer it using diagrams. So imagine that I have thought about multiple diagrams and I could come up with these three scenarios. Okay. These three scenarios. In first scenario you have one machine. Okay. You have single machine, the read write are happening to this single machine from multiple users. So what would happen if this single machine goes down? Yes. In the first case is the classic relational database kind of environment where you have a single machine which does everything for you. And this single machine has got 16 cores and 200 MB, 200 GB RAM. So all the users are reading from the same machine and writing to the same machine. So in case this machine goes down for some reason, none of the users ever get catered. That means it's not partition tolerant. Similarly, if more and more users are coming in, after a point in time, this machine may not be able to handle. So the availability is low, but consistency is superb. As in, whatever one user writes the data instantaneously, immediately, if the another user is coming in, they'll see the fresh data. Now, in the second model, the second architecture is a MongoDB kind of architecture. We will see it later also in case of Zookeeper and others. There are two machines, A and B. User write to the A and the readers read from B. Okay, so writers go to A, readers go to B. If the same user wants to write and read, most likely he's going to write to A and he's going to read from B. Now, since these are two machines in the network, data takes time to go from A to B. Okay, data takes time to go from A to B. All right. Therefore, if the data takes time to go from A to B, therefore it is inconsistent. It is not really consistent because say you wrote just now some data to A and started reading it immediately. Now read request go to B and the data is you will keep on seeing the old data. It's very very awkward for people who are coming from RDBMS background to see that they just inserted some data and when they did select star, they're seeing the older data and they keep on panicking that what happened to our record, we just added. Okay, and the reason is the time is being taken in transferring data from the writer from this A to B. Okay, therefore such system is not consistent. Third one is, but it is the second system here is basically available, as in if A node goes down, B contains the data, writers will shift to B and readers will continue from B. Similarly, that means it's a partition tolerant. Available, it's definitely more available than one machine because there are two separate machines giving you the availability. Third model is A and B. Can anybody tell that where did we see this kind of architecture? Anyone? All the users are reading writing to A. There is a copy of A is maintained in the backend. This B is not being used unless A goes down. If A goes down, then B takes the place. Correct. Thank you, Webhub. So the third model is where we saw it in HDFS. That's correct. Thank you. So where we had the primary and secondary. Primary will keep on serving to the users and secondary will be as a standby. Awesome. All right. So we have that. Okay. And so here in case A goes down, there is a copy of A available, and therefore it is partition tolerant. But it is not still available. Meaning in case there are lots of users, are still all of the users are reading from A, therefore A is the bottleneck, and hence the requests are not really distributed, therefore it doesn't have availability. Okay, now Matthew's question is, but availability is limited if more people are accessing. That's correct. Yes. All right, makes sense to you, everyone? So this is the reason why there is a cap theorem. Okay, I hope I'm able to explain. And this, when we say in these kind of databases, so most of the databases actually settle down to this middle level, this one or this one. Okay, so Matthew's question is, what is the solution for e-commerce? So most of the users, what they do is they keep two kinds of databases. Let's take a case of Amazon, for example. Amazon, most of the critical accounts related data is kept in Oracle. The critical data, where the consistency is the primary thing, the kept is still in the RDBMS. Rest of the data is in a, a database. Rest of the data is in this kind of database. All right. So that's the way most of the e-commerce companies are architected. There are generally two forms of data storage. One which keeps the consistent data, the transactional data. Rest for the NoSQL kind of database is for everyone else. All right. That's pretty much about NoSQL. If you have any questions, let's discuss it after the break. Let's take a break for 10 minutes. Come back at 8:46. Okay. Let's come back at 8:46. All right. Should we start now? I'm back. Should we start now? Leonid is back. Matthew is back. What about others? Alright, Deepak is back. Alright, should we start? Alright, let me just then take it forward. Alright, so the capturing part is clear to everyone? Any doubts, or do you think there are other architectures which are good? Do you have any other architecture in mind? Kiran's question is, can't we mix second and third approaches? Very good point. Thank you, Kiran. Yes, we do. We do. So MongoDB is a result of this mixing. Okay. So there is something called replica shared, sharding, and all that, so that this basically gets divided. All right. So we generally mix and match things, and that's why, because of the various combinations of these, you get many different kind of databases. All right. Now, what architecture does Spark use? So Spark is not really a NoSQL. It's just a computational uh, platform where it reads data from a NoSQL, and then you write the logic for Spark and it runs that. Okay. Good questions. And moving on. So Kiran, was I able to answer your question? All right. Next thing which we need to understand before we move forward to NoSQLs or to HBase is what exactly is column-oriented database. A column-oriented database is the data in columns stored nearby as opposed to the data in rows. Okay. So what does it mean? If you have seen CSV file, the way it stores data, first imagine that this Excel sheet is being stored as CSV file. So in a CSV file, how will we store data? 10, comma, Joe, new line 12, comma, Mary, new line 11, comma, Kathy. So you can see that the values of a row are together. Okay, values of a row are together while values of columns are spread across. Okay, values of columns are not together. So those are the kind of databases we call them row oriented, where the data of a row stays together. Now there are another kind of databases, new genre of databases called column oriented database. So some researchers found out that if you store the data of a column together, the compression results are far better. Why? Because data in a column tends to have the same data type. And if you have same data type and you try to do a compression, the results are far better. Okay? Okay, so basically we are storing the data of columns together. So it will be stored 10, 12, 11, and then Joe, Mary, Kathy. Okay, 10, 12, 11. Joe, Mary, Kathy. This 001003 is basically a mark of row number. Okay, it's just a mark of row number saying that how to identify each one. All right. Now here you can see that all of the column values have come together while storage. In representation, in logical representation, both row oriented and column oriented database look exactly same, but the difference lies in the storage. Okay, so Matthew's question is it like a log file? Yeah, log file is also like top down. You keep on storing from top to down. All right. But in column oriented, you have all the column values staying together in the physical storage. All right. Is it clear to everyone? Because this takes a bit of understanding both of the aspects. Anyone? So everybody is clear about what exactly is a row oriented database? So Matthew is saying, so you are saying that there are not many rows. Let me try to understand. Okay. So, okay, here we are discussing the differences between column-oriented database and row-oriented database. Okay, in row-oriented database, the values of row stay together, while in case of column-oriented database, values of columns stay together. Okay, stored together, I would say. Okay, so Matthew is saying that here. So you are saying that there are not many rows, it has got only two columns. So it doesn't matter how many rows we have, how many columns we have. Okay, imagine that there were thousands of columns. So first thousands of columns. So all those thousand values will be stored first, and then next thousand, next thousand. That's how the row oriented works. But in case of column oriented, all the column values come first. First a column is stored, then next column, and then next column. All right. So we have question from Leonid. Does the columnar database take more space? No. So the sole purpose columnar or column oriented database is same. The definition for the is the same name. Okay. So columnar or column oriented database have been designed with the perspective of making it more compressed, taking it less space. All right. We have another question. So ID will be used to match up and represent. Yes, that is correct. The row ID which we have marked as 001, 002 and so on will be the one which will be used for which we will use for matching it up. Okay, good. And yes, in uncompressed, next question is in uncompressed. So this is an interesting question. So okay, this is Leonid's question. Continuing with the does columnar take more? So in compression, it takes less time. But his question is, what if the data is uncompressed? Does it take more space then? So there are only a very small differences in the storage, very small oriented I mean, if you look at it here, the total values are same. If you have a look at it, 1 2 3 4 5, right? here 1, 2, 3, 4, 5. Where did this go? Did we miss something here? This is 10, Joe, 12, Mary, 11, Kathy. Yeah, it will be 6, right? 1, 2, 3, 4. Oh, did I miss anything? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, oh, okay. This is correct. 1, 2, 3. Yeah. 1, 2, 3, 4, 5, 6. That's correct. Yeah. So the storage, if you look at it, it won't take too much of time. It's looking like it will take more time, more space. All right. And follow-up questions. So Leonid's question is they are not. You might have to store row ID with the column value. But you can always instead of row ID, you could also say column ID kind of thing. We could say column ID, colon, and then array of values. Okay? Array of values. So internally it's used as a different strategy. Okay? So it all depends on our storage strategy. So if we have exactly same way like row oriented one, the space will be same. Instead of marking row ID on every value, we'll mark column ID then, right? All right, good, very good. Kiran's question is this approach may increase insert time. Very good. Yes, it might increase the insert time. That's a good point. So all right. So lots of people also observed that in these kind of databases, when people are trying to alter an existing data, the column editing is also equivalently intensive. As in, we are adding more columns, deleting more columns, and updating existing column and so on. Okay, so keep that in mind. It's a good point which you have raised, that inserting a row will take more time in case of columnar database. That is correct. But at the same time, in the row oriented database, inserting a column takes a lot of time. Okay, so it's a trade off, and that's what, when you are designing your system, keep that in mind, so that you can take the benefit of adding columns rather than adding rows. That's why when we design in HBase, you will notice that we will be designing in a way that our table can add more and more columns as we add rows. Okay, very good. So one more question which I missed is here from Matthew. This is Matthew's section. So you are saying in a column oriented database, the info is not sequentially matching the row. Okay. Okay. In column oriented database. Mhm. Okay, let me just try to understand. So you are saying in a column oriented, the info is not sequentially matching the rows, because so far it looks like It's SQL table. Okay, info is not sequentially matching the rows means this info is not sequentially matching the. No, they will match. They will match. Yeah. So yeah. So Matthew's question is, so what is the difference between this from an SQL table? Okay, it is only from the user perspective, it is the same. If you look at the table, it looks like exactly the same as RDBMS. The difference is the way it is stored on the disk. In column-oriented database, the storage of all the values in a column are stored together. And in a row-oriented database, the values in a row, like 10 Joe, will be together, 12 Mary will be together, 11 Kathy will be together. Okay, that also brings us to another reasoning that adding the rows in a row-oriented database, we just need to append that line in the file, right? But in case you want to add a column in a row-oriented database, it's a big problem, right? Similarly, if you want to add a column in case of column-oriented database, it's pretty straightforward. But in case you want to add a row in a column-oriented database, it is difficult. Make sense, Matthew? The difference from the RDBMS? Representation-wise, it's same. It's the difference is in the way it is stored. Great. All right. Now, HBase, which we will be discussing today, they did a clever thing. They said we are neither column-oriented, we are nor the row-oriented. We are flexible. So they came up with something called column family. So, and they said that a column family is basically a group of columns, and it is column family oriented database. Okay, meaning the data in a column family is stored together. So first in the disk, column family one's data will be there, then column family second's data. Instead of column oriented, this database is column family oriented database. Okay. All right. Matthew's question is, so you can't use SQL query in this. You can use SQL query. It is possible to use the SQL query, just that not HBase doesn't provide a native SQL query engine. There are other tools which provide the native SQL one. Okay, so let's talk about column families. A column family is basically a group of columns. Like for example, here there are two column families, CF1 and CF2. CF1 contains employee ID and name. CF2 contains the age. And here the way the data gets stored is all the data of a column family is stored first, and then column family 2 is stored. Okay, the difference here is that the column inside the column family, the data is stored row wise. So 10 Joe, 12 Mary, 11 Kathy, 10 Joe, 12 Mary, 11 Kathy. After that, 23, 33, 45. Okay, good Kiran, thank you very much. It's a good question. Good point. So, Kiran's question is, so do we have to create column family at the table creation time? Yes. So while you are creating table, you mention that this is my column family 1, this is my column family 2, and so on. Okay. You give a name to each column family. All right. So basically in this, now quick question to all of you. Let me see if you can answer that. Question to all of you. All right. If there is one column family per column. Okay, per column. Then is it column oriented or row oriented? So if we have one column per column family, okay, if we have one column per column family, then is it row oriented or column oriented? Anyone? Correct. It is column oriented. Now imagine this. So we are talking about, imagine this, we had three column family, column family 1, column family 2, and column family 3, right? And this will get stored first, then this will get stored first, and then this will get stored first. That means it is behaving like a column oriented database. Okay. Now if there is a one there is if all columns are in a column family, if they in your table, if in your table there is only one column family and in that column family all columns are there, then is it row oriented or column oriented? Let's look at it again. Had it been only one column family in the whole table, so will it behave like a row oriented or column oriented? Vaibhav, Kiran, Matthew. If we had only single column family for all the columns in this table, correct, it will be row oriented. Good. All right. Now you can feel the the design differences. Sounds good. All right. Let me answer two more questions. We have question from Leonid. So Leonid's question is, can column family be modified after that the table already exists? No. Modifying a column family is okay. There are two ways to look at it. Coming back here, you can add more columns into this column family as and when you want. Okay. You can keep on adding as many as columns as you want in a column family. Okay. But you cannot change number of column families. You cannot add more column families. You can add more columns but not column family. Okay. Or neither you can change the column family. Make sense to you? Leonid's question is, would it be similar to reindexing? It will be more like copying the data to somewhere else. Okay. If you have to create another column family, the only way to do that is you create a fresh table and then move data from here to there. Okay. Next question from, I missed one question from Kiran. Do so again, same question from Kiran also. Okay. Kiran was question is, can we alter? I'm assuming we can alter column families after some data is inserted. Yes. Again, same thing. So you can add columns but cannot change column families. Okay. If you want to change column family, create fresh table and move the data. All right. All right. For new columns, we may still define a column family. Yes. So while inserting the data or while inserting the call, this is from WebHub. For new columns, this is for new columns, we may still define column family. Yes. So you can keep on adding as many as fresh columns as you want, but in the existing column families. Okay. Now, next question from Kiran is, can I interchange the columns from two column families? As in interchange, as in you will have to delete a column from one and add in another. Similarly, add from the right and add to the left one. So you can add and delete, there is no issue with that. It's not that these are hard coded, there can be n number of columns. Unlike our traditional design where we had fixed number of columns, here there is no such thing. You can add as many columns as you want, and you will see it further that HBase makes sense only if you have millions of columns. All right. Okay, I think the time is come to move ahead to so that we can talk about the data, the data model. You will understand that. All right. So let's introduce HBase. HBase is a column family oriented database which has consistency and partition tolerance but not great availability. Although there is availability, but instead of availability, HBase goes for the consistency because it has got single master which accepts reads. All right. So HBase is a column family oriented database with consistency and partition tolerance, but not availability. It is based on Google's Big Table. Out of the three papers, the one was Google File System, MapReduce, and third one was Big Table. Okay, so it is based on the third paper called Google's Big Table, and it's great for storing hundreds of millions of or billions of rows and is strongly consistent and not eventually consistent. Okay, it's not eventually consistent. It has got automatic sorting in the sense that as and when the data keeps on adding, that the tables keep on dividing into multiple tables. Okay, so that's automatic sorting. And it has got something called automatic failover, and it has it is basically the actual data of HBase is stored in the HDFS itself. Okay, so it has got this, it is basically based on HDFS. It is massively parallelized process using MapReduce. If you have to churn billions of rows in HBase, you can simply write your MapReduce code. Okay. The API of HBase is available in Thrift as well as Java. And if you have some API in Thrift, that means the API is available in almost all languages on the planet. Okay, all programming languages on the planet. And we have got coprocessors in this HBase so that they behave like server side stored procedures. Okay, and then to make the search faster, it has got Bloom filters. All right. The architecture of HBase is very clean in the sense that on top of HDFS and Zookeeper we have already gone, we have not gone through. We'll go through Zookeeper soon in the next session. Okay. So Zookeeper is for coordination between various services. You can think of Zookeeper as like a traffic light, so that master can discover region servers. So on top of SDFS and Zookeeper, you have master and the region servers. Okay, master keeps track of metadata, as in which row is where, and region servers store the actual data. Okay, master keeps a track of which row ID of the row is on which region server, and there are many region servers containing the data. Okay, now HBase API, uh, HBase API provides an interface, an interaction between the user and the HBase. Okay, so HBase API is in Thrift, which you can use to get the data. Okay, again, the architecture is very simple. Architecture is such that you ask master that where is my data, here is my row ID, and master will talk to the region server, find out where. Master will keep a record that from this range to this range of row IDs, the data is in this region. For this range to this range row ID, the data is in the other region server, and so on. So master keeps the data in the form of ranges. Okay, in the form of ranges, because if there are a billion IDs, master does not store all the billion IDs. Instead, it keeps a range saying that from this range to this range, data is in this region server, and this range to that range, data is in other region server. Okay. All right. So this in the same thing is depicted here also. The region server keeps on storing the data in HDFS. Same is master, and master discovers its region server through Zookeeper, and each region server region server reports its attendance to Zookeeper. So as and when you are adding more and more region servers, you keep on telling Zookeeper that we have got one more region server, and so on. In case any of the region server goes down, Zookeeper is immediately notified, and afterwards it no longer displays that region server to the master. And master keeps a track of the data, tracks of which region server contains what, using Zookeeper. Zookeeper is like a traffic light. All right. All right. Again, so initially what happens is when you are inserting data, there will be only one reason. There's only, so you create a table, there will be only one reason. All right. The information about the table's metadata is with the master. The actual data goes to reason server. So initially, initially a table will have only one reason, and when the table starts growing, when more and more data is coming into tables, okay, when more and more data is coming into tables, the table will start expanding, and the moment the table reaches a threshold, it will split into two parts, and these two parts will become two separate regions. And as and when these two parts independently, as they keep on growing, and they itself will become grow beyond threshold, both of them, they will break into four parts, and that breaking will keep on continuing, and to make sure that the data is properly distributed. Okay, so initially there was one table. As it grew, it became two. As these two portions grew, they became four, and so on. Now, out of these four, you are whenever a row is added or deleted, all these operations are happening on a section of the table, which is called reason. All right. So tables are automatically partitioned into horizontally into regions. Each region comprises a subset of tables rows. A region is denoted by the table it belongs to, its first row and the last row. Last row is not included while first row is included in a region. Okay, that's the representation part. Okay, visually you can represent the same thing like this. Okay, so keys from A to C is not included, which means A, B are on region server 1. TUVWXY is on again region server 1. There are two regions, and so on. So you can see that the full table is broken down into 6 regions stored on 3 region servers. Alright, let me try to reply to Webber's question. What is the difference between region servers and distributed storage of HDFS? Okay, so region servers store regions into HDFS. Okay, the regions will be stored. Each of these will create a separate HDFS file. I'll show you this, and then it'll become very clear to you. Okay, so HDFS will be storing these sections of the data in the HDFS. Will have replication and all of that. If these regions are bigger than the blocks, then it will get broken down into multiple files. There's a question from Leonid. Are row letters corresponding to the key letters somehow? Yes. So we are assuming here that the row ID, so every table is supposed to have a row ID. And here A means a row ID. Okay, just for simplification reason, we have just kept a single letter row ID. So Kiran is saying HDFS means it should have replication factor block. Yes, yes, Kiran, you are right. That when I say that this data is stored in HDFS, which means data will further have the blocks and will have splits and will have replication and so on. Okay. Vaibhav, did I answer your question? Now, question from Leonid is, how does that relate to key T to Z? Okay. Key T to Z means keys starting from T up to the Z but not included to Z. Okay. So all the keys, so there'll be a like this region you see, it will have a table which will have the row ID starting from T to Z, T to Z. Okay, there'll be a row with T and there'll be cells and so on. All right, that's correct, Vaibhav. So the region servers are HBase's DB storage, which further gets pushed into HDFS. Correct. So the okay. Okay, so the arrows don't really mean they are between A and H, for example. Where is it? Oh, you're right. So this range is like, yeah, you're right. So it doesn't mean that it's coming from here. Yeah, I got it now. What you mean? So here it doesn't mean when you say key A to C, it doesn't mean that we are talking about these range of rows. Okay. All right. But yeah, it's a good point. I think the way we could have designed it is that we could have taken this block here, right? And took brought this block from there to here and so on. I think it's a good idea. All right. All right. Then. Good. That could have been a better design. Yeah. All right. Now the most important part when we talk about NoSQL, HBase or anything is to be able to do the data modeling. And data modeling is part of any developer's life. And the most time and the biggest effort it took me was in understanding the data model. All right. Although it's not complex, it's pretty simple. It's just that it was not explained to me properly, as well as it was not so intuitive. So the first time I was designing my database in Cassandra, it took me lot of time to basically realize that why exactly are we having this kind of design, because I was coming from a relational database background. I'm really sorry. I've got a little cough. So question from Kiran is, what is the advantage of column family over row slash column level oriented? Good, good. The simple answer is probably these two set of questions. With column family, you get the flexibility of using row level or column oriented approach. Okay, so basically the benefit of having a column family oriented database is you are very flexible. Some part of the data is going together, so you put them in column family and so on. Okay, so it gives you a flexibility to choose between the two or go with either of the models. All right. Now, probably the best definition for the data model is from the big tables paper. I could not take a single word out of the main definition, not a single word. Okay, all these six keywords actually represent the definition of big table. Let's go from right hand side. Big table is a map means it has got key and values. Okay, key means row id and value means any object. Okay, so that's big table. It's a map. It's a sorted map, meaning the keys are ordered. If we get hold of the first key and you start iterating to the next key, alphabetically we will hit the next row id. Okay, next row id. So I mean in the increasing order. So it's a sorted map. It's a multi-dimensional sorted map. The values are further broken down. So there is a key, there is a value. The value is further broken down into multiple columns. That's what it means by multi-dimensional. It is persistent, as in if there is no electricity, no power, the data doesn't disappear. Okay, because it is persistent, it is saved in the disk. Then is distributed. It's a distributed, persistent, multidimensional sorted map. Distributed means a table is on multiple machines. So when I say distributed database, it means the database table is distributed across the cluster. Okay. Next is sparse. Sparse means it is not necessary to have all the values in all the columns. Okay. You are free to only fill few values in a column. Two columns in a table need not have same set of columns. Okay, that means sparse. So these are the definition of the data model. Yes. So Kiran's question is how do we design which columns to make column family and which columns to which will optimize and enhance. Okay. So we will discuss it in detail, but for time being, let me try to give you a single line answer. The data which you want, the data having the same axis pattern or similar axis pattern will be in a same column family. Like for example, first name and last name. Every time you ask somebody's first name, you also query for the last name. Therefore, first name and last name should go in the same column family. Okay. Or similarly, if you are inserting or updating some data, all those columns which have the same axis pattern, they go in the same column family. Good. Very brilliant question. Keep on going. Yeah. Keep on asking questions. Yes. Thank you, Vaibhav. That is a probably better answer. Address line 1, address line 2, address line 3, zip code, pin code, they can be part of the same column family. They have to be because they have the same axis and updation family. Yes. All right. Great. So HBase organizes data into tables, and and table names are safe for the file. Table name cannot be anything. Okay. When you are creating a table name, it should not have special characters like colon and single quote, double quote. Okay. It should be safe for the file system. Okay. Next is the row. A row contains within a table the data is organized into rows. Rows are identified by row key. Row keys do not have a data type and are treated as byte array. So note this line. We know about table, we know about rows, but this is something which you need to understand. The row has got a ID. Just like when we are defining a table like here, like not here, in our Excel sheet, we give a row number to each one. Similarly, we can give the name to each row, and that name can be a huge binary data. Row key can be a binary data. You can store the full movie into the row key. This is something non-intuitive to me. It was something non-intuitive to me. But when we realized that the row key can contain the full array of data, we started utilizing that information. Okay? We started storing binary file as the row key. Alright? That is another interesting aspect. Then is column family. So data within a row is grouped by column family. Column family impacts the physical arrangement of the data. They must be defined upfront and are not easily modifiable. Every row in a table has same set of column family, but that does not mean every row need to insert column into every column family. Okay, and just like table name, column family name cannot be binary. It has to be plain text, which is safe for the file system because we are going to create a an HDFS file with the column family name. Okay, we are going to create an HDFS file for each column family. Therefore, the column family name should be file system safe. Okay, a column qualifier is just like row ID, but it's like column ID. It's a column identifier. Okay, again, the way we could push a lot of binary data into the row name or row ID, similarly, we could push a lot of data into column ID. So data within column family is addressed by column identifier, and qualifiers need not be specified in advance. Column qualifiers need not be consistent between rows, meaning not every row is bound to have the same set of columns. As a matter of fact, HBase doesn't really care. As a matter of fact, you will have lots and lots of columns in one row, and the other one will have completely different set of columns. Okay, so that's why it's called key and the value. It's more like key and the value. All right, we have question from Kiran. So here we are denormalizing the child tables and storing those in a single table by creating column family. Brilliant, brilliant. Yes, that's what we are doing. So what he's saying that, okay, let me just paste it. So here we are denormalizing that. Basically, we are trying to store the whole data in a single table. Within the single table, the subsections of the data are going as column family. Okay, keep this in mind. Again, column qualifier can be binary. Next is cell. Cell is the actual storage of data, and cell can have binary data. Also also when we talk about cell, the value in the cell has got versions. Okay, and version numbers, which is difficult, which is by default is timestamp. Okay, the version ID is timestamp. If you do not specify any version, it takes up the current timestamp. Similarly, when you are retrieving data from the cell, you will get the latest data automatically. Okay, and so the number of versions retained by HBase is configured for each column family. By default, there are 3 versions for each cell in the table. Okay, this information you can utilize. Again, let's go with an example. We'll go with 2 examples so that you can understand the architecture of HBase. So far, we have only talked about theory. Let's take a look at the first example. Here, we are trying to build probably a phone book. Row key is 1, 2, 3, 4, 5. Column family, there are 2 column families. You can see the 2 column families. One is called personal, other is called official, office. Under personal, there are 2 columns. One is name, other is residence phone. Under office, there is phone and the address. Okay, and each cell has got multiple regions. Okay, all right. The multiple timestamps. Next is this is how it's located. You can look at it as a multi-dimensional sorted map in this following manner. Okay, under under an ID there is an office and personal. That's a column family. Then under that column family you have multiple columns. Under the multiple each columns there are timestamps. Under the timestamp there are a cell value. Okay, so this is the way you can hierarchically imagine the edge space. All right, here is a little difficult example, and this example is very important. Why is it important? Because that's how Google stored the data. That's how Google stored the data. All right. So the reason why HBase, I mean, the big table was invented by Google for this particular example, and based on this example only, we will do the explanation of the data model. All right. So here we go. Let's imagine that let's dictate the purpose also. What exactly are we trying to do? We are trying to store the data from across the globe, from the World Wide Web. We are trying to build a corpus of the data, an index of the files into this huge table, so that we can do various kinds of intelligent things on top of this data. Let's imagine that. Okay, 22 August, 7 a.m. All right. All right. Let's take case by case before we move forward. You have any questions? Let's take few examples here. All right. So here let's take a case of, let's imagine that there is a website called www.cnn.com. Okay, www.cnn.com. Okay, in this what we are doing, we have got this HTML. We have got this HTML, and it is having some HTML content. Okay, now there is another table called, there is another website called cnnsi.com. Okay, it has also some website, has some HTML. Okay, and this inside this HTML, it's referring to say www.cnn.com as CNN, like this. Okay, my.look.ca. Okay, so there are these three websites: cnn.com, cnnsi.com, and my.look.ca.com. Ca. Okay. Now Google encountered this first, so Google downloaded their data. Google downloaded their data and entered into HBase. Okay. So to do that, first they created a scheme in which the row ID will be the website ID. Okay, website URL, Then there are two column families. One is called anchor, other is called contents. All the contents which a crawler encounters, it is pushed into contents column family with an empty name. All the HTML content is being pushed into a column with an empty name and a column family called contents. Okay, so and all the information related to the links that are referring to this website go into the column family called anchor. So we are basically trying to do two things. One, who is having what HTML content. Similarly, we also want to find out who is referring to who. Okay, so we took the content of the website, we pushed it into content section. Then then we moved on. We found another website after some time which is having some content, and so we put that as a new row here. There'll be second row, and we find that inside this content it's referring to cnn.com. Okay, so cnn.com is being referred to by the second one, so we add a column in the anchor column family with this domain name and put the cell value as the name with which we are calling it. We are calling it CNN. Therefore, therefore we are putting the cell value. So column name is the website name who is referring this website. Similarly, myloop.ca is also referring to CNN www.cnn.com as cnn.com. So we got one more anchor here. So this row basically says that for www.cnn.com, this is the content of the HTML. This is the website which is referring to this cnn.com as CNN. Then there is another website called my.look.ca which is referring to www.cnn.com as cnn.com. Okay, up to here everything is clear to you? No? So Kiran is saying that can you repeat? Does anybody else want me to repeat? Right. So okay, Matthew is saying one column for HTML, one column for, yes. So the something which is very different here, something which is very different here is, as and when we are getting more and more website, we are also adding more and more columns into this table. As we encounter a website, we download its data. That time we create a row into this table, and then when we parse the data and we find out which all websites are being linked from this newly downloaded website, then we add those many columns. So for this, I think a better thing, what should I do? I should basically create an Excel sheet. Yeah, that's a better idea. They'll give you a feel. They'll give you a feel. Let me repeat once, Kiran, for you. Okay. Now, Vaibhav's question is, how is anchor being defined? Anchor is a column family which we have already defined, but we are adding more and more columns into that column family. Okay. Let's try to do that. HBase. Okay. So let me try to define row ID. This is what is our data model. Okay, this is what is our data model, and contents. Okay, and then anchor. And under the contents, we are merging these cells just to give you an effect. Okay. And under anchor, I'll show you in a better manner. Okay. So we have got contents column family, and we have got anchors column family. Okay, so first we encounter the this website, so we put this as the row ID. We'll talk about there will be a minor change in row ID. I don't want to get that complication right now. Okay, and let me just put it this way. This is our column family. Okay, this is column family, so I'm putting column out with this. So we defined a table which has got row ID. Row ID is always there, so we don't need to define. It has got two column family. One is called contents, other is called anchor. Okay. Next is we add one column family. Let's say empty. This is our empty column name. Column name can be binary, so it can be empty. And we encountered that this is our HTML. Okay, this is our HTML. So we put that HTML here. There is no website being linked by www.cnn.com. Happy? So we encountered our crawler, our beautiful crawler, downloaded this website and made this entry into HBase. Everybody okay till here? Vaibhav, Kiran, Deepak, John? All right, great. So everybody okay till here? Then crawler came to know about another website called cnnsi.com. It created an entry here. All right, and then it found this HTML. Okay, and put it the HTML. Now at the second stage, after downloading this HTML, it realized that this HTML need to be parsed, and after parsing it realized that, oh, cnnsi.com is actually linking to www.cnn.com. So it finds from this table who is www.cnn.com, and in that table what it does, it adds an anchor. It adds an anchor. Okay, it says that cnn.si.com is referring to cnn.com as CNN. So note that this is our column name. This is our column name. So we added one column which has got value in only one of the rows. This is empty. Rest of the things are empty. Okay, so anchor.cnnsi.com. After a point of time, we encounter another another website called mylook.ca, and it has got this nice content in this form. Okay, you can see that. I think I made a little mistake. Yeah, this is okay. This is okay. This is okay. We are referring to cnn.com here. Now, mylook.ca will after parsing this data, we'll create one more column here called mylook.ca. Okay, and then we'll say that this website is being referred as cnn.com. All right, so this is one way of organizing data. Let's say we encounter another website called microsoft micro microsoft.com, and it has got an href to cnnsi.com. Okay, like this. In that case, we'll add one more column as Microsoft, and we'll say here CNNSI. Now you can see that here we did not add value for this or this or this. In the same case, we did not add value. Okay, this is our column family. Let me merge it. Okay, so this is our column family. These these are our rows. So this is how we design. This is how we design the database in case of HBase. Yes, yes, Kiran. So yes, we are adding columns dynamically. Yes, this is where that column family oriented thing comes into play. Okay, so you can see we are adding, as and when we are encountering data, we are adding rows as well as we are adding columns into the table. Sounds good? Everybody okay with this description? If you have any questions, just let me know. I would like to answer that now. Okay? Anyone? All right. Okay. So if you have no questions, I'm actually very happy that you got it, or maybe you did not get it at all. Everybody okay, right? As and when the data grows, and this is how it is going to go. Okay. Now there is another important aspect which we are not exploiting yet, and that aspect is the row key is sorted. Meaning, if we encounter www.cnn.com, we can go to the next row and next row. These will be sorted. Let me try to sort it for you. Okay, let me try to sort it for you. How can I make freeze these two rows? Okay, so let me try to sort this data. Okay, data sort range. Data has got this, and okay, maybe I need to do something else because it's not allowing me to sort based on. No, I can't sort it that way. Okay, so what will be the better way of sorting? The only way I can, okay, I think I got it. And I can sort the data. Alright, now you can see few things here. This data of CNNSI and CNN.com is far apart. Okay, similarly, imagine that there was another website called blog.cnn.com, right? And there was some data here. Now these will be far apart from each other in this model, right? Because this row is going to be somewhere here, right? Now if we want to get all the data from cnn.com website, then it's very difficult right now, correct? Because this data is sorted by the row ID. So we could actually utilize this property of HBase into our benefit. So instead of storing it in the forward manner, we could do one more clever thing. We could say our row ID is com.cnn.blog. Okay, com.cnnsi.cnnsi, com.microsoft. Okay, ca.look.my, com.cnn.www. Okay, so we reversed it so that when you sort this data, if you sort this data the way I was trying to sort it, if you sort this data, then you will notice that all those websites with the same name, all those websites with the same name will be together. You can see cnn.blog and www.cnn have come together. Okay, so we are exploiting one more property of this, of HBase, in order to solve our problem. Okay, instead of saying microsoft.com, we are storing microsoft com.microsoft, so that in case we hit com.cnn, we know that the next row and next row would be most likely same domain as this current one. Okay, so that we can cleverly collect all the data together and do analysis of all the website of one particular domain together. So subdomain will always be together here. Sounds good to you? Is this clear? Why did we reverse it? Awesome. Yeah. Any Vaibhav, Kiran, Leonid, John? Good. Now Kiran's question is, what if the website is of this form? Then there is no solution. Honestly, there is no solution right now. If you have cnn.in, if you have cnn.in and uk.cnn.pk and all that, then it is going to be difficult here. Then this model may not work. All right. Sounds good. This may not work. Then you might have to think about some other scheme, or maybe you can consider cnn.in and cnn.com as completely separate websites. All right. So this was about the data model in HBase. And if you are able to understand this part, rest of the part are easier, because this is something which need a little time to digest. So that's why there is one of the assignments. You can have a look in the No Big Data my courses. The assignment is to build an email kind of storage using HBase. You have to build an email storage using HBase. All right, you have to do that using HBase. Okay, so that's pretty much for today, and tomorrow we will just do a recap and have a look at the internals. Right. All right, thank you very much. Have a great day ahead. Bye bye.